Weight shift control 11.3 approaches and landings. Navigating through turbulent air and mastering crosswind approaches and landings are essential skills for any pilot, especially those flying weight shift control aircraft. In turbulent conditions, a power-on approach with an airspeed higher than usual becomes the pilot's tool of choice. This provides more energy and positive control in the face of horizontal gusts, wind shear, or drafts. Practice this in calm conditions before taking it to turbulent skies, and always maintain ample power until the main wheels make contact, avoiding abrupt movements that can lead to a hard landing. Crosswind approaches and landings add an extra layer of complexity. The basics of a regular approach and landing still apply, but now pilots need to employ nuanced techniques to counter wind drift. Adjusting the pattern to account for crosswind drift is crucial, widening it to allow for maneuvering room. During the final approach, embracing a crab angle, heading into the wind with wings level, helps maintain alignment with the runway centerline. The wind's influence continues during touchdown, with rear wheels hitting first and swinging the nose around. If the front wheel touches down first, pilots should steer lightly to follow the carriage's direction, lower the nose, and use the wing's aerodynamic braking, along with wheel brakes if necessary. Understanding the limitations of maximum crosswind velocities is vital for safe takeoffs and landings. Pilots should consult their aircraft's manual for specific crosswind limitations and refer to wind charts to make informed decisions. Recognizing a strong crosswind during the downwind leg, modifying the pattern accordingly, and opting for a go-around when necessary are crucial skills. Attempting landings in crosswinds that exceed personal or aircraft capabilities should be avoided, as should inadequate compensation for wind drift during various phases of the approach and landing. Mastering power on approaches in turbulent air and navigating crosswind challenges requires a combination of skill, practice, and situational awareness. Imagine you're making your approach in a weight shift control aircraft. Steep approaches could be your secret weapon. Picture this: it's better to be a bit too high than way too low, especially if the engine decides to take a break. Steep approaches are like your safety net, ensuring you reach that landing point even if the engine throws a tantrum. Now, there are two flavors of steep approaches, or sometimes a mix of both. The choice depends on how steep you need to descend to hit your landing bullseye within 400 feet. Whatever you pick, one golden rule: pull that throttle back to idle. Let's talk about the first type, the steep angle approach. Say you need a bit more descent angle for your landing spot. Easy fix: crank up the speed above your best glide speed. The faster you go, the more drag you create, and that means a steeper descent angle. But here's the kicker: different trikes behave differently. Single surface wings with exposed crossbars go all in on drag with increased speed, creating a sharp descent. On the flip side, double surface wings with a sleek carriage don't get drag happy as quickly. Know your trike. It's like knowing the personality of your favorite partner. Okay, got the speed up? Good. Now, stabilize that approach. Get the right angle for your aiming point. At these higher speeds and a steeper descent, ease back to your normal approach speed, lock into the regular final approach path, and smoothly slide into your landing routine, be it in calm air, crosswinds, or a bit of turbulence. As you get comfy with steep approaches, you can start your roundout at a higher altitude than your typical approach. Keep in mind, though, that the extra speed during the roundout means covering a bit more distance. Plan accordingly as you dial down the speed. That's your steep angle approach, a slick move to ensure you hit your mark, no matter what curveballs the engine throws. When facing a situation where a steep approach is necessary but the aircraft is too high to achieve the desired steep angle, alternating turns can be employed to gradually decrease altitude to a level where the steep angle technique can be applied effectively. These turns should commence no lower than 400 feet above ground level and need to be equal in distance from the runway centerline extension to maintain track and relative position on the centerline. The direction and bank of these turns across the runway centerline depend on the altitude loss required to position the weight shift control aircraft for the steep angle technique in the remainder of the descent. Power-off accuracy approaches are essential for instilling in pilots the judgment and knowledge needed for accurate unpowered flight and safe landings in emergency engine-out situations. Estimating the gliding distance to a landing spot is a fundamental aspect of these approaches, with the ability to maintain proper glide during aircraft maneuvering also crucial. Altitudes up to approximately 1,000 feet can be estimated accurately with experience, but accuracy decreases above this level due to merging features. Altimeter indications are a valuable aid in judging height above ground level, and the pilot's ability to estimate gliding angle and resultant distance is paramount. In power-off approaches, where power is fixed at idle, pitch attitude adjustments control airspeed and, consequently, the glide or descent angle. Lowering the nose steepens the descent angle, and vice versa. The pilot must avoid stretching a glide to reach the desired landing spot, ensuring a safe and controlled descent. Various uniform approach patterns, such as the 90 degrees, 180 degrees, or 360 degrees power-off approaches, are detailed, offering pilots a basis for developing judgment in gliding distance and planning approaches. The 180 degrees power-off approach from pattern altitude is emphasized as the normal landing procedure in calm winds, fostering the ability to accurately judge landings in engine-out situations. The basic procedure for power-off approaches involves closing the throttle at a designated altitude and gliding to a key position, which serves as a reference for judging whether the glide safely terminates at the desired spot. The selected key position should be appropriate for available altitude and wind conditions. Throughout the approach, the pilot must consistently evaluate the situation, prioritizing safe and well-executed approaches and landings over pinpoint accuracy. To prevent conflicts with normal traffic flow at busy airports, instructors should carefully evaluate the place and timing of power-off approach practices. This evaluation is particularly crucial for the 360 degrees power-off approach. The 90 degrees power-off approach, initiated from a base leg, requires a 90 degrees turn onto the final approach. The positioning of the base leg can be adjusted based on wind conditions. The glide from the key position on the base leg through the 90 degrees turn to the final approach represents the final phase of all accuracy landing maneuvers. Steep approach procedures may be employed during the final approach if necessary. The 90 degrees power-off approach typically begins from a rectangular pattern below normal pattern altitude, provided this point is above 500 feet AGL. The before landing checklist is completed on the downwind leg. Following a medium bank turn onto the base leg and obtaining the key position, the throttle is fully reduced to idle, and the airspeed is set to approach speed. At this position, the intended landing spot appears to be on a 45 degrees angle from the aircraft's nose. Wind strength and direction can be determined by the amount of crab needed to maintain the desired ground track on the base leg, aiding in planning the turn onto the final approach. The base to final turn is executed to align the aircraft with the runway centerline, with slight adjustments in pitch attitude for glide angle and airspeed control. It's emphasized never to stretch the glide to reach the desired landing spot. Once the final approach glide is established, full attention is dedicated to executing a good, safe landing rather than focusing solely on hitting the selected landing spot. In any event, it is preferable to execute a good landing 200 feet from the spot than to make a poor landing precisely on the spot.